video, we from Group 3 will explain about the content contained in black liquor and green liquor. Before that, allow us to introduce ourselves. The cooking process is carried out using the carve or sulfate process, which is the process of cooking wood chips using a mixture of sodium hydroxide and sodium sulfate solutions. The resulting pulp is called carve, which comes from the German word for strong. Sodium sulfate in the cooking solution is obtained by reducing sodium sulfate in a recycling kiln. Sodium sulfate itself is not capable of forming pulp from wood. There is also a cooking method that uses it, and is called the sulfate process because this salt is used as a material to replace chemical loss during the process. The next explanation will be delivered by Agnes.
White liquor is a cooking solution and from a liquid solution of sodium hydroxide and sodium sulfate with a molar ratio of approximately 5 NaOH plus 2 Na2S and with a pH between 13.5 until 15. White liquor is made by the pasteurizing process from green liquor using limestone or CaO, where if green liquor is read with lime, it will produce white liquor and H2CO3 plus CaO plus H2O become 2NaOH plus CaCO3. This is isothermic reaction. The reaction occurs very quickly, approximately 18% of the causticity. Reaction occurs with 10 minutes, and green liquor apart from sodium carbonate. There is also sodium sulfate, which has many effects and must be considered in the system, where the sodium sulfate will be hydrolyzed to from sodium hydroxide and sodium hydrosulfate. The reaction is Na2S plus H2O become NaOH plus NaS.
Okay, next, the main content of black liquor are sodium hydroxide NaOH, sodium sulfate Na2S, and sodium carbonate Na2CO3. To maintain the quality of the white liquor, then will be is cheap cooking. Is necessary to analyze the total treatable alkali, the total amount of sodium hydroxide NaOH, sodium sulfate Na2S, and sodium carbonate Na2CO3. Quantization efficiency is the percentage ratio of the concentration between sodium hydroxide NaOH to the of sodium hydroxide NaOH and sodium carbonate Na2CO3.
In the pulping process, if a large amount of causticizing efficiency is obtained, the concentration of white liquor, where is only a small amount of Na2CO3 concentration contained in the white liquor, where Na2CO3 is an impurity in the pulp, and in large quantities it can cause gall in the digester unit, reducing the base cross section of the digester.
The composition of white liquor in sulfate pulping is called sulfidity, which is the ratio of Na2S to active alkali expressed as Na2O. The sulfidity used varies according to change in the amount to active alkali, temperature, cooking time, and a number of other factors. The effect of sulfidity in the manufacture of pulp or sulfate pulp compared to the manufacture of soda pulp show that the rate of delignification is faster in the manufacture of pulp or sulfate pulp, which is achieved 90% delignification with half a day of the time required to manufacture soda pulp.
The black liquors out of the evaporation process has a solid content of about 70 to 83%. The inorganic part, about 45% of the black liquor dry mess, consists of sodium carbonate and sodium sulfate. Due to the presence of inorganic material, the lower heating value per ton of black liquor solid is 12.3 megajoule per kilogram. A pulp mill produces 1.7 to 1.8 tons of black liquor dry solid per tons of pulp and represent 250 to 500 megawatt of potential energy per mill, producing 1000 to 2000 hydrate ton of pulp per day. In pulp and paper mills, black liquor is considered as a major energy source that can be used to produce synthetic gas, which results in various valuable energy products such as electricity, methyl ether, synthetic natural gas, methanol, hydrogen, or synthetic diesel, and has the potential to replace conventional black liquor recovery system with recovery boiler.
2. Na2S or sodium sulfate. Sodium sulfate is compound that is very easily oxidized. Therefore, this substance is widely used, especially in situation where reducing agent that is not too strong is needed. For example, for bleaching wool, silk, and as anti-chlorine agent. Bleaching of woven treats the textile and paper as a food preservative. About 60% to thread material are used in paper industry. Sodium sulfate in the chip cooking process functions the first to reduce damage to carbohydrate and provide higher yield and higher pulp strength. Next is to accelerate the reaction between NaOH and lignin by reducing activation energy of the reaction.
Sodium carbonate, Na2CO3. In the pulping process, this sodium carbonate solution is made up or impurity in the white liquor cooking solution, where the where the sodium where the sodium carbonate solution is an inactive alkali in the chips cooking process. However, through the process of decausticizing sodium hydroxide or NaOH with the addition of calcium carbonate or CaCO in liming in the lime clean where the resulting sodium hydroxide will be used as the main cooking solution for the next chip cooking process. The craft pulping process uses wood chips as the main raw materials and alkaline chemicals as a supplement to remove lignin. Through an environmentally friendly process that can contribute to the reduction of greenhouse gases. Black liquor is a waste from the paper industry. The content contained in black liquor is water, inorganic chemical cooking materials in the form of sodium salt, 50% lignin, and other organic materials separated from the pulp during the cooking and washing process. Organic, organic components make up as much as 60% of the total black liquor solid. Table 1 shows the elemental composition of black liquor.
The next material is about elemental composition of black liquor from craft process. First, carbon. Carbon in black liquor has a function as fuel. Black liquor is a byproduct of the wood bleaching process in the pulp and paper industry. The carbon in black liquor provides energy when burned in a boiler to produce steam and electricity in the production process. Second, hydrogen. Hydrogen is a light gas, lighter than air, colorless and odorless. If burning doesn't show any flame and will produce very high heat. Third, oxygen. Oxygen is an active and latest chaining component of the atmosphere. Oxygen is colorless, odorless, and tasteless. Oxygen is very easily oxidized and oxygen reacts strongly with combustible materials, especially in its pure state, and releases heat in the reaction process. Many reactions require the presence of water or are accelerated by catalysis. Fourth, sodium. Sodium serves to bind lignin so that black liquor is formed and lignin dissolution occurs by white liquor from wood fibers without damaging the wood fibers.
5. Potassium. The element potassium is a soft, silvery white alkali metal that oxidizes quickly in air. If it reacts violently with the water, it will produce enough heat to ignite the hydrogen emitted in the reaction and burn with a purple flame. Number 6. Sulfur. Sulfur is a chemical element that has a pungent odor and is usually found in volcanoes, where it can be processed into a white powder. Black liquor is made by heating a liquor that contains organic materials from wood, especially lignin, an organic chemical used for delignification. In the craft process, the addition of sodium hydroxide or NaOH and sodium sulfate Na2S and two wood sheet result in the extraction of lignin and hemicellulose from insoluble cellulose fraction. Black liquor comes out of the cooking process with a solid content 15 until 18%.
The black liquor that comes out of the evaporation process has a solid content of about 70 to 83%. The inorganic part, about 45% of the black liquor dry mess, consists of sodium carbonate and sodium sulfate. Due to the presence of inorganic material, the lower heating value per ton of black liquor solid is 12.3 megajoule defeat kilogram. A pulp mill produces 1.7 to 1.8 tons of black liquor dry solid per tons of pulp and represent 250 to 500 megawatt of potential energy per mill, producing 1000 to 2000 hydrate ton of pulp per day. In pulp and paper mills, black liquor is considered as a major energy source that can be used to produce synthetic gas, which results in various valuable energy products such as electricity, methyl ether, synthetic natural gas, methanol, hydrogen, or synthetic diesel, and has the potential to replace conventional black liquor recovery system with recovery boiler.
Okay, next, green liquor. Green liquor is solute of sodium carbonate, sodium sulfate, and other components from recovery boiler is the craft process. The green color are received from the process of chlorida ion sulfida. Green liquor is usually reacted with TAO at the concentration thanks to regulator formed by dissolving the base recovery system mixed in water. The main content The main components are sodium carbonate and sodium sulfate and contain small amount of sodium hydroxide and sodium sulfate. Liming can be used to recover sodium hydroxide because its content little iron hydroxide is color is green. So is color green liquid.
Okay. Green liquor undergoes a settling process phase to remove impurities or dregs containing terrain. The clarified green liquor is then reacted with quicklime or CaO. Under control condition from sodium hydroxide or NaOH and calcium carbonate, with its called the recausticizing process. The elements contained in green liquor are as follows. The first is Na2CO3. Na2CO3 is cooking solution in making pulp through the sulfate process. NaCO3 function to dissolve lignin during the pulping process, thereby speeding up the process of the separating and breaking the fiber.
Two, Na2S. Na2S is a chemical compound consisting of two sodium atoms and one sulfur atom. This compound is usually solid, has a brownish yellow color, and has a characteristic odor. Na2S is water-soluble compound and has a strong alkaline properties. Na2S is usually mainly in the pulp and paper industry in craft process. They increase the selectivity of the sulfate refining process and increase the rate of delignification. 3. NaOH, sodium hydroxide, is an inorganic chemical compound, also known as a caustic sodium or sodium hydroxide. This compound is from the element sodium hydroxide and oxygen. Sodium hydroxide usually takes the form of a white solid that is highly soluble in water, producing a strong alkali solution. Sodium hydroxide is used in the paper making process after the wood fiber is separated through pulping. Sodium hydroxide is used the subsequent processing process such as fiber bleaching and pH setting to the produce quality paper. Green liquor will be converted into white liquor with the add CaO to the recausing process.
Smell obtained from the high black liquor combustion process will first be dissolved with water to become green liquor in the dissolving tank. The smell solvent is weak white liquor or WWL, which come from the recausticing unit, which is the result of lime mud washing. After that, the green liquor will be processed into white liquor using the recausticing process. Smell is made from Na2CO3, Na2S, Na2SO4, and Na2SO3. Smell inert is soluble components such as K, Mg, Mn, Fo, and all are content in smell as well. With wash liquor from the weak wash store, tank is fed to dissolving tank to dissolve the smell. With wash content small amount of NaOH and Na2SO3, components dissolve in water.
The recausticizing plant is designed to produce strong and clean white liquor containing a minimum amount of unreactive chemicals for the cooking process. Green liquor which is produced as a byproduct of burning black liquor and burnt lime from the lime kiln, are used as raw materials. The processes in a recausticizing plant are the following. It starts with green liquor handling. The basic purpose of the green liquor handling is to filter green liquor coming from the recovery boiler dissolving tank so it can be suitable for recausticizing. Green liquor is pumped from the recovery boiler dissolving tank to a raw green liquor tank. The purpose of the raw green liquor tank is to stabilize the concentration, temperature, and flow fluctuations in incoming green liquor. The raw green liquor tank also acts as a storage tank between the recovery boiler and the green liquor filter. The lime green filter is a pressurized filter which separates dregs from the raw green liquor by cross-flow filtration. The pressure difference across the filtering surface forces part of the liquid through the element. A circulation pump sends the green liquor to the top of the filtering elements, and the large downflow prevents the dregs from forming a cake. The capacity of the lime green filter is controlled by the pressure difference across the filtering surface. Clean, filtrated green liquor is sent to the green liquor tank. Concentrated dregs are discharged periodically from the filter. Green liquor temperature must be reduced in most mills prior to the recausticizing. This is done in the green liquor cooler, which is a combination of an expansion vessel and a heat exchanger, both operating under slight vacuum. The next process in the recausticizing plant is green liquor dregs handling, which means dregs washing, dewatering, and removal from the process. This happens in the lime-free dregs centrifuges. The purpose of the green liquor dregs washing and drying is to replace the liquor in the dregs suspension with alkali-free liquid water. The original liquor, which is slightly diluted, returns to the process. The washed dregs are discharged as dry waste from the process. The following processes in the recausticizing plant are lime slaking and causticizing. Green liquor and lime are mixed together in a predetermined proportion in the slaker classifier. The first reaction is lime slaking, and it takes place in the lime slake. The causticizing reaction starts immediately after slaking. Grits which may remain from lime are removed as waste from the process in the classifier. The rest of the causticizing reaction takes place in the causticizer tanks. The causticizing line consists of 3 causticizers connected in series. Their purpose is to give lime milk sufficient retention time to complete the reaction to obtain white liquor filtration. Then, white liquor and lime mud resulting from the recausticizing reactions follow to the white liquor filtration. They are separated from each other in the lime-white filter. The most important goal of separation is to produce clear white liquor without any residual lime mud. The white liquor separation is based on pressurized disc filtration. Filtrated white liquor is pumped from the lime-white filter to the white liquor storage tank. Lime mud is pumped to the lime mud storage tank. The final process in the recausticizing plant is the lime mud filtration. Lime mud from the lime mud storage tank is pumped into a vacuum-type disc filter. The purpose of the lime dry filter is to wash alkali away from lime mud and raise dry solids content to a suitable level before it is fed into the lime kiln. The quantity and the density of the lime mud pumped into the lime dry filter are precisely controlled, as these values determine the lime kiln production. alkaline liquids and filtrates produced in the process are called weak wash. They are collected and stored in the weak wash storage tank and from there pumped to the recovery boiler dissolving tank to control the green liquor density.